All right, so in this video, we're going to look at actually trying to use some trigonometry for a few different things. So we just have a few scenarios that we're going to look at. The first one here is a person is in a lighthouse that is 75 meters tall. They look down 32 degrees, see a boat. How far away is the boat from lighthouse? Okay, so first things first, I'm going to start labeling what I have. I've got a person's lighthouse 75 meters tall, so this would be the 75 meters right there. So it's 75 meters tall. And they're looking down at 32 degrees, see the boat. So they are looking at the boat, which is out this way, and they're looking down at 32 degrees. And if this angle here is 32 degrees, well, then this angle here would also be 32 degrees. So I'm looking for how far away is the boat from the lighthouse, so I'd be looking for this distance right there. So there's my little right triangle that I'm going to, well, basically going to solve for. So if I'm looking for that part at the bottom of the triangle, I'm looking for the adjacent. And if I look at what information I've got the angle 32 degrees. I've got the 75, which is opposite from the 32. So I've got the opposite. I'm looking for the adjacent. I need to use tan theta. So tan theta is opposite divided by adjacent. I've got the tan of the angle, tan of 32 degrees. The opposite is 75, and the adjacent is what I am looking for. So again, this is like that cross multiply and divide thing. So I will do the 75 times the invisible 1 underneath the tan 32, divided by the tan of 32. And I've got around 120. So bottom part would be 120 meters. So that is about how far away the boat is from the lighthouse. Okay, so let's go to question number 2. A woman's fishing, catches a fish. The fish is at 38.2 meters out in the water, and the fishing line makes 24-degree angle with the water. How long is her fishing line? Okay, so again, I'm going to label a bunch of stuff that's going on. The fish is 38.2 meters out in the water. So the fish is out. Here, I'm even going to draw a little. Here's my little fishy over there. There's my fishy. Okay, so the fish is 38.2 meters out in the water. So the fish is 38.2 meters out in the water. And the fishing line, of course, the fishing line goes from the fishing pole to where the fish is. And it says the fishing line makes an angle of 24 degrees. So that's 24 degrees in there. And I'm looking for how long the fishing line is. So I'm looking for that length right there. Okay, well, if I look what I've got the angle, and I've got the adjacent to the angle, and I'm looking for the hypotenuse. So adjacent and hypotenuse, that would be cos theta. So cos theta is going to be the adjacent over the hypotenuse. So cos of 24 degrees is going to be 38.2 divided by the h, and h is what I'm looking for. So I can just, again, cross multiply divide type thing. So 38.2 times the one that's not there, divide that by the cos of the 24 degrees, and we get about 41.8 meters. So she's just under 42 meters of fishing line out, holding on to that fish. All right, let's try the next one. We've got shadow and the tree. This is using shadows is a very common way to find the height of objects for thousands of years. It's true. In fact, using shadows is how some ancient cultures actually found the distance to the sun and stuff like that. It's actually pretty cool. You measure the shadow of the tree to be 15.6 meters long. The sunlight's coming at 60 degrees. Okay, again, let's label some stuff here. So the shadow is 15.6 meters. So this is 15.6 meters going out this way. And the sun's coming in an angle of 60 degrees because, of course, the sunlight's coming in, which creates the shadow in the first place. And the sunlight comes in, and apparently this is making a 62 degree angle in there. And we're looking for the height of the tree. So we're looking for the actual height of the tree. Let's see, I got the angle, I've got the adjacent to the angle, and I'm looking for the opposite. So this looks like tan theta again. So tan theta would be opposite divided by adjacent. All right, so I've got tan of 62 degrees. Opposite is what I'm looking for. The adjacent is the 15.6. All right, so now I can find my opposite. So I'll take the tan of the 62 degrees and then multiply that by the 15.6, and we get an opposite of, give or take, 29.3 meters. Okay, so pretty tall tree, so 29.3 meter tall tree. All right. Last question we have is Billy climbs up, aims his Nerf gun at a negative 25 degree angle. Often when if you're angling down, like the sun question or even the lighthouse question, often degrees are given as negative angles. The bullet went straight for 19.3. That's pretty good for a Nerf gun. And how far up did he go? Okay, again, let's label what's going on here. So negative 25 degrees, so he angled down 25 degrees, and his bullet went for 19.3 meters. So if the 25 degree angle up here, if that's 25, this is also going to be 25 degrees. And we're looking how far up he went. So we're looking for this distance there. Well, there's basically my triangle. So if we look what I've got the 25 degrees down the bottom right. I've got the 19.3 is hypotenuse, so I'm looking for the opposite. So I've got opposite and hypotenuse, so that'd be sine theta. So sine theta is opposite divided by hypotenuse. And I've got sine of 25 degrees is equal to, opposite is what I'm looking for, the hypotenuse is 19.3. So I'm going to solve for the opposite. So we can do the sine of 25, we'll multiply that by the 19.3, and we get about 8.2 meters. So he climbed up about 8.2 meters. Okay, that's it. Okay, now when you have the triangles, when you have like people angling down and stuff like that, it doesn't really matter if you would use this triangle here or this triangle here. It doesn't matter. The 25 degrees, some people like to use the triangles, from the angle that's given. Some people just move the angle to the bottom. It doesn't make any difference. It's the same triangles. You'll get the same results whether you solve for the height on this triangle, which is over here, or solve for the height of that triangle over there. It's going to be the same answer. It doesn't matter. Okay, so there's some practice using trigonometry in a couple different scenarios and situations. You label the stuff, you label the sides, which sides do you have, which side are you looking for, and that sort of tells you which trig function you can use in any given situation.